My dear students, now we are going to look at higher order Demux design. So in this design, what exactly we are trying to do is we are taking a lower order demultiplexers in order to get a higher order demultiplexer. Before going to the design, we will look at what exactly the Demux operation as a review quickly. Then we will go for the design part. So as we know, demultiplexer will have only one input. Here we are taking D in. Okay. Then two outputs for what exactly known as 1 is to 2 Demux. This is what exactly represented here. S0 is selection line, En is enable, Din is data. Now if you look at the truth table, so what is the truth table? Input output relations. What are the inputs? Inputs are enable, Din and S0. So this exactly the truth table that we are looking for. If at all you look in the table, there is a enable which is equal to 1, then your demux is working. S0 is input, D in either it may be passed to Y0 or it may be passed to Y1 based on the input S0. So when S0 is 0, your output Y0. How many outputs I have? Y0, Y1. This is input. These two are outputs, right? So when 0, Y0 is D in, Y1 is 0. When S0 is 1, Y0 is 0, then Y1 becomes Dn. I mean to say it is passed to Y1. S0 is equal to 0, Y0 is Dn. When S0 is equal to 1, Y1 is Dn. Okay. When Y1 is Dn, Y0 is 0. When Y0 is Dn, Y1 is 0. So this is one has to understand. Once this is clear, okay. Now we will look at 1 is to 4 Demux. 1 is to 4 Demux. In this Demux, we will be having one data line D in, one enable line, input, two selection lines. Okay, I say 0 and 1. So one is LSP, another one is MSP. How many output lines? 4 output lines. Y0, Y1, Y2, Y3. D in data, enable, active high enable. So when active high enable is there, what exactly that we are trying to do is this. When enable is 1, it is functioning. When enable is 1, this is functioning. So this enable is 1 is a condition such that it is working. Now I have couple of inputs, S0 and S1. Of course, Din is also input. Then we have couple of outputs. These outputs are nothing but input positive outputs. So they are they are they are going to receive from the input what exactly the D in is. So for 0 0, Y0 is D in, but rest all are zeros. For 0 1, what is the meaning of that is I am choosing, okay, what I am choosing from selection lines, whether D in to be passed to Y0 or Y1 or Y2 or Y3. Okay. For 0 0, it is passed to Y0. For 0 1, Y1. For 1 0, Y2. For 1 1, Y3. What about the rest of the lines? When the rest of the lines will be 0. Rest of the lines are 0. Say for example 1 1, D3, D in is available at Y3, but rest of the lines are 0. So if you look at this, what is this 0 0 0 1 1 0 Y1? This is sort of min terms, right? We are choosing Y0, Y1, Y2. So this Y0, Y1, Y2 by choosing S0, S1 we are selecting that is nothing but you are choosing the min terms. Okay. So Y0 is min term 0, Y1 is min term 1, Y2 is min term 2, Y3 is min term 3. Okay. So these are the min terms available from the demultiplexer. Whereas in multiplexer, I taught that this 0 is M0, this is M1, this is M2, this is M3. These are the min terms. which we are passing it to the output. Okay, these are the set of inputs I have. Okay, where we are calling it as I0, I1, I2, I3, right? S0, S0 selection lines. What is this? Is 4:1 mux. Okay, this 4 corresponds to min terms M0, min terms M1, min terms M2, min terms M3. Okay, what is min term? We know. What is min term? Sum of product term. So this is nothing but from S0, S1, if at all you see, this is S0 bar, S0 bar, S1 bar. This is the min term for M0. Okay, multiplied by D in, of course. Okay, so it means to say ANDed. It's not multiplication and operation. Similarly, if you want M1, M1 is S1 bar, S1, S0, S1, S0 bar, S0, S1. Okay, these are the min terms that we are going to get it. These min terms are useful when you are solving a problem. Okay. Next, we will look at the real design. The real design that we are looking for is, I would like to design 1:4 Demux using 1:2 Demuxes. How many I require is 2. How do we make the calculations? How many outputs I need is 4. How many outputs I have is 2. So 4 by 2, 2 more. That means if I have 1:2 demultiplexers, I can get all required outputs. So all required outputs, I am putting 2 demultiplexers. This is Demux1, Demux2. Input should be only 1. So what I did is just I have combined inputs of both the demultiplexers, right? Then the selection line, which is only 1, which is combined for both of them. Okay. Output is Y0, Y1, Y2, Y3. Now S3 is used. Actually, there are 2 selection lines for 1:4 Demux. 2 selection lines, because it is 1:2 power 2, where this 2 is selection lines. But only S0 is used to choose one out of 2, Y0 or Y1, Y2 or Y3. Okay. Now we are going to use S1 for selection of either 1 or 2, Mux1 or Mux2, Demux1 or Demux2. Right? These outputs are 0, 1, 0 and 1. Okay. So now what this Demux1 or Demux2 is chosen based on the S1. So when S1 is 0, what I am trying to do is, this is 0, output is 1. So this is enabled. When this is 0, this is also 0, this is disabled. So this is off. Whereas this is on. So this is functioning. Now if S1 is equals to 1, 1's complement is 0. So input is 1, 1's complement is 0. Now input is 1, same 1 is going to reach over here. Earlier it was off, now it becomes on. Earlier it was on, now it becomes off. Why it becomes off? 1's complement is 0, so it is going to off. Now this is going to function. So on the whole, what I can say is, when S1 is 0, okay, Demux1 is enabled or on, this is off. When S1 is 1, Demux1 is off, and when S1 is equals to 1, Demux2 is on. So this is how S1 is used, okay, in order to select any one of the demultiplexers through the enable pins. What I can say in simple words is, enable pin is going to save the power in one way. Okay, the other way is to have higher order demultiplexers, higher order demux. We are going to use these enables appropriately with extra selection lines, okay, such that, okay, you can get the higher order demultiplexer. This will be more clear if I take another example wherein I would like to design 1:16 demultiplexer from 1:4. So how many output lines? 16. How many I have? 4. 16 by 4 will give you 4. So I need 4 1:4 demultiplexers. I need 4 1:4. So I have 1, sorry, 1 second. I have 1, 2, 3, 4. 4 outputs, y0 to y3, y4 to y7, y8 to y11, y12 to y15. Okay, I am having 4 selection lines, S0, S1, S2, S3. 2 selection lines are required for 1:4 demultiplexer, which I am going to use as S0 and S1. I left with, actually if I look at 1:16, which requires S4 selection lines, S3, S2, S1, S0. S1, S0, S1, S0 used. 2 left over, right? So this S2, S3 I am writing, representing here. This S2, S3, what I am trying to do is, I am trying to choose one out of the 4. I will choose 1 when 0, 0, 0, 1, 1, 0, 1, 1. For that, what I am going to use, when 0, 0, I am putting it to the inverter. I am giving it to AND gate. This is will be enable for what? For mux 1. Similarly, when this is 0, 1, what I am trying to do is, I am going to use one inverter for which this is S2, S3. So for this is S2, S3, right? So for S3 there is inversion. S2 directly I am going to connect, mute the AND gate. Now this is enable for second mux, for mux 2. Similarly, it is being shown for this inverter, for this wherever 0 is there inverter, no inverter. For this directly, okay, AND gate, giving it to AND gate, giving it to AND. So this is all we are generating. Enable input, this is enable, this is also enable, this is also enable. Okay, so this is how what we did. For all of them input is same, D in. All D ins are combined together. This is D in, this is D in, and this is D in. Data in, D in, okay. This is D in, this is also D in. So D in are combined, only one D in we have. Okay. So what extra that we did? Just what extra that we did is very simple, that we have only one input, 4 selection lines, 2 selection lines to choose one out of 4 within the Demux. Within the Demux, I am using S0 and S1 to choose one out of 4, one out of 4. To choose one out of 4 demultiplexers, I am using S2 and S3 with this logic gates. Okay, I am choosing the one. Done.